Okay, it's recording now. Okay, so as I was saying, H plus is responsible for acidic properties, okay? So all acids produce H plus, and H plus is the reason why you see all these properties of acids. And when do they produce H plus? Acids produce H plus when they are dissolved in water. All right, so that's why you see all the state symbols there are AQ, meaning aqueous. Now, there are 5 physical properties of acids. I think the first 3 you should know very well. Firstly, acids taste sour. That's obvious to you by now. So many of the fruits that you eat are sour because they contain acids. Okay. Next, acids turn moist blue litmus paper red. And acids also turn universal indicator red. Okay, but universal indicator, there are other colors like orange or yellow. Okay, depending on the pH. But typically, most acids in the lab will turn universal indicator red. So the acids you have in the lab are the 3 on top here: HCl, HNO3, H2SO4. So these 3 acids are very acidic, so they will turn universal indicator red. So the first 3 you should already know. Now the fourth one, acids have a pH value less than 7. Okay, so for example, if the pH value is 6.7, it's acidic. If the pH value is 2.0, also acidic. 0.9, also acidic. So anything below 7 will be acidic. All right. Now, finally, acids conduct electricity in aqueous solution. And this is because there's H plus ions, which are free to move. Okay. So this one page, right, importantly, you need to know is H plus. H plus means acid. H plus is responsible for all these properties you see listed here. Okay. Next, you should know the colors of indicators with acids. The predominant color here is red. Finally, pH value of acids less than 7. Okay. Now moving on is the next page. The next page is the heavy one. The next page where you have the 3 important reactions of acids. And this is where we spend a lot of time. You need to know these 3 reactions well. The first one, you have learned it under metals as well. Acid plus metal forms salt and hydrogen gas. So importantly, please remember metal. If you start from metal, you must always get hydrogen gas, okay? Now, whenever there's a gas produced, you need to test for it. So how do you test for the hydrogen gas? You insert a lighted splint into the mouth of the test tube. All right? And then they will always ask you, what are the observations for the positive test? The observations is that the gas extinguishes the lighted splint with a pop sound. So this is important to learn because you've seen this so many times in your metals homework as well. All right. Now, regarding the equation, how do you write this equation? So importantly, you need to know from the question, what is reacting with what? The question will tell you hydrochloric acid, magnesium. So you're going to translate it into chemical formula. So it's HCl plus Mg. What does it form? It forms magnesium chloride. Now, how you know it's magnesium chloride? The salt must always start with the metal's name. In this case, magnesium. The second part is from the acid, okay? So hydrochloric acid becomes chloride. So magnesium chloride. How you know that it's MgCl2 though? You need to work out charges. Mg is 2 plus. If you go to periodic table, magnesium is group 2. So it loses 2 electrons, so it forms 2 plus. Chloride is Cl minus. That's why the formula is MgCl2. You need 2 times the chloride to balance out the 2 plus charge on magnesium, okay? And remember, hydrogen gas is H2. Anything ending with gen is diatomic, 2. And with that, to balance the equation, you just need to put 2 in front of HCl. Okay? Now, as Mr. So has said, balancing equations is a process. You have to think through the steps first. Write down the formula correctly, meaning you must write HCl correctly. You must write MgCl2 correctly. If you don't do this correctly, right, then no point. The equation will not be correct. So take it slow, be patient. Okay, so like Faiz, okay, you need to write out the charges, okay? Don't just straight away MgCl, no. You need to think Mg is 2 plus, Cl is minus, okay? Now, on this note, you need to know there are some metals that are unreactive. This one, I think you took down in class. So if you have the notes, you take out, you don't have to copy again, right? Now, there are some metals that are unreactive with acid. There are three important ones: copper, silver, and gold. These three metals don't react with acid. So if you put them into acid, right, nothing happens. No reaction occurs. And that's because they are below hydrogen in the reactivity series. Can? So not all metals react with acids. Some metals like gold, silver, they won't react with acids, okay? Can? So what must you learn? Must learn the reaction. Acid plus metal forms salt and hydrogen. Secondly, must learn test. Test for the gas, hydrogen gas, how to test. Thirdly, you must learn which metals cannot react with acids. Okay, these three. Okay, because they are below hydrogen. Finally, learn how to balance the equations. Write slowly. Think through the charges, okay? But I'm sure you see a pattern by now. We always test the same few acids, the same few metals. So it's important for you to be familiar with these metals like magnesium. You should know by now that magnesium will form Mg2 plus ions. Okay? Now, second reaction. Acid react with base to produce salt and water. So what is a base? Base is basically metal oxide, metal hydroxide. So from the name, you can tell, right? The question will give you the name of the chemical, right? So you read sodium hydroxide. Sodium is a metal, hydroxide. Sodium hydroxide is a base. So immediately you know, okay, sodium hydroxide is a base, therefore it's this reaction, not acid plus metal. It is this reaction, acid plus base, because it's a hydroxide. Okay? Now, acid plus base forms salt and water. So unsurprisingly, if you read what is formed, it's salt and water. Salt and water obviously is neutral. Right? So you have learned things are acidic, things are alkaline, things can also be neutral. Neutral means pH 7. So water is pH neutral, 7. Salt as well, pH 7. And that's why this reaction's name, neutralization. Okay, you need to know the name of the reaction. The name of this reaction is called neutralization because you form something neutral. Okay? So the equation as well, let's zoom in on the second one maybe. Let's zoom in on this one. Hydrochloric acid plus sodium hydroxide forms sodium chloride and water. How on earth do you know it's sodium chloride? Well, the salt must always start with the metal. So you got to ask yourself, what is the metal in this equation? The only metal is sodium, right? Sodium is the only metal. Hydrogen is not a metal. Chlorine is not a metal. So must be sodium. So the name must start with sodium. Why chloride? So the second part of the salt's name, you look at the acid. What is the acid? Acid is HCl, hydrochloric acid. So it's chloride, sodium chloride. Okay, so it forms sodium chloride and water. So this is neutralization because you form salt and water. Okay? Can, up to this stage, 2 reactions already. 2/3 done already. Last 1/3. Acids plus carbonates. Carbonate, carbonate. The name says it all. Carbonate forms what gas? Carbon dioxide. This is always true. Even when you reach Sec 5, right? Okay, you will learn this again and you will learn more. Carbonate, if you start with carbonate, you always produce carbon dioxide next. So if step 1 got carbonate, step 2, carbon dioxide is formed already. So you need to know how to test for carbon dioxide. Bubble the gas into lime water, you form a white precipitate in lime water, okay? Can? So you need to know the test for hydrogen gas, test for carbon dioxide gas. All right? Can? So the principle behind writing this equation is the same. write the formula correctly first. So you must be very, very careful when writing formula. Now, the trick to writing formula is to be familiar with the ions. So like I said, magnesium, so commonly tested, you should know that magnesium is Mg2 plus in a compound. Then carbonate, no choice, got to memorize, right? CO3 2 minus. So now, once you have written out the charges, isn't it obvious that it's 2 plus and 2 minus? So the plus and minus are balanced out, so it's just MgCO3. Okay, then do the same. Magnesium chloride, you need to know Mg2 plus, but chloride is not 2 minus. Chloride is only minus. So how? Different charge cannot. Must make the charge the same. So how? I need 2 chlorides. That's why it's MgCl2. Okay? Can? Now, this one page is very important. Please learn it well. I'm not saying this for your WA1. I'm saying this in general for N levels. Okay? If you look at the N levels for the past 10 years, definitely the questions won't test difficult equations. Rarely do they do that. Usually it's an equation and a reaction you have learned. What reactions have you learned? These 3 reactions. So being familiar with these 3 reactions really helps you improve a lot. And that's why most people who work hard will pass combined science, simply because they will only test you one of these 3 reactions usually. Okay? When you learn the reaction, learn the products, learn the test for the gases, okay? Okay, at this stage, maybe I should pause for just 2 minutes to see if you have any questions you want to unmute to ask. Otherwise, you can type. All right? You can type into the chat, I can see. Okay, 10 more seconds for people to type. Okay, so there was a question about which ions you must memorize, right? Now, the list of ions to memorize, you can take down. I would say importantly, you must know these ions. Okay, so some of you might remember last year, Miss Shahida and I will come into class, then we will ask you to give us what's the formula of sulfate, what's the formula of carbonate, what's the formula of nitrate. So these are the 5 ions that I think are the most important at the moment. You have the hydroxide, you have the nitrate, carbonate, sulfate. And of course, Zn2 plus is zinc. Zinc is also commonly tested at the N level, so you should know the charge formed by zinc. All right. So if you can memorize these 5, honestly, you will go very far already. Okay. So I leave it here for about 30 seconds for you to copy down if you need to copy down the 5 ions to memorize. Okay, 20 seconds more, then we move on to the next page. Okay, if you recall, these are the same ions that we put into your periodic table, right? So the periodic table that we printed out for you, I hope you haven't lost it. Okay, the ions are listed there as well. These are the ions that are most commonly tested, so you should learn them bit by bit. Okay, I'm not expecting all of you to be experts at writing the formula immediately, but we should make improvements. Maybe this time round, you have to learn, say, carbonate well, so that you can write something, right? So maybe you want to learn carbonate, then you learn sulfate, then you learn nitrate. Slowly you improve, all right? Okay, so this page important for N levels in general. So these 3 reactions spend time, investment of time. All right. Now the next page, the opposite of an acid is a base. Okay, so we mentioned just now, bases are metal oxides or metal hydroxides. So if you read, sodium hydroxide is a base. Magnesium oxide, base. The moment you see metal oxide, metal hydroxide is a base already. All right. Now, bases react with acids to form salt and water. So let's recall, what is this reaction? Forming salt and water. The name of the reaction is neutralization. Okay, Ken? So need to know the name, the name. Okay, so what is alkali then? So that day I I went through this rather quickly. Now, alkalis are bases. So what's the difference? Alkalis are soluble bases. This means that they dissolve in water. Okay, so alkali is special. Alkali is a base that can dissolve in water, and when it dissolves in water, it forms hydroxide ions, OH minus, and that's why we say OH minus is responsible for alkaline properties. This one I think you have copied down that day in the notes already. Okay, so let's try to recall. Alkalis must have OH minus, acids H plus. Separate these two. These two are opposites. Acid H plus. So just now was H plus. Now alkali OH minus, hydroxide. So what are the common alkalis in the lab? You have sodium hydroxide, calcium hydroxide, and aqueous ammonia. In particular, the last one may be more difficult for you to grasp. Okay, you can see that aqueous ammonia, wow, where got hydroxide, right? There is no oxygen at all in the formula. But do you notice it forms this? It forms ammonium ion and hydroxide ion. So aqueous ammonia sometimes can also be called ammonium hydroxide. Now, I didn't include the word ammonium hydroxide in your notes because, okay, the exams rarely use this word ammonium hydroxide. They will just use aqueous ammonia, but they are the same thing, okay? Okay, just give me a minute, okay? I'll be back in 1 minute's time. Give me a minute. Okay, so I hope you have taken down that OH minus is responsible for alkaline properties. So what are the properties of alkalis? You will notice that the properties of alkalis kind of are the reverse of acids. So in terms of taste, alkalis taste bitter. So your bitter kind of food, like bitter gourd. Bitter gourd is bitter because it contains alkalis inside the vegetable. Okay, alkalis feel soapy to touch. And that's the reason why alkalis like sodium hydroxide is used to make soap. So if later on you just go to your soap bottle, you look at the ingredients, right? You will see some of these alkalis in your soap. In particular, sodium hydroxide is typically used to make soap. Okay? Now, in terms of indicators, that's what you need to know very, very well, of course. Alkalis turn red litmus paper blue. Alkalis turn universal indicator blue or purple. So you must remember, most alkalis in the lab should turn universal indicator purple. For example, sodium hydroxide will turn it purple because sodium hydroxide is very alkaline. Okay? Next, pH. Alkalis higher than 7. So just now you had lower than 7 is acid. Alkali is higher than 7. Now, higher than 7 means what? If it's 7.4, it's also higher than 7, okay? So 7.4 is alkaline already. 7.4 is the pH of your blood. So your blood is alkaline. 12.0, also bigger than 7. So it's alkaline, okay? Can. So this page, important to also study. What to study? You need to know the alkalis, OH minus is responsible for the properties. You need to know the color, blue, purple with universal indicator. You need to know pH, okay? Now moving on is the reactions of alkalis. The first one is basically neutralization. Acid plus base gives salt and water. That's neutralization. That one you already know under acid. Okay? Now, it's the second one that is often forgotten. This is the one that we picked quizzes that day. A lot of you forgot. There's this thing. Please know that alkali or base can react with ammonium salt, and this gives ammonia gas. You need to know the test for ammonia gas as well. Ammonia gas, ammonia is alkaline, so it will turn moist red litmus paper blue. Okay? So an example is if I mix sodium hydroxide. Sodium hydroxide is an alkali. with ammonium chloride, ammonium. Okay, ammonium is the keyword. So once there's ammonium, you mix it with sodium hydroxide and heat it up slowly, it will produce ammonia. Ammonium produces ammonia. All right, it's always like that. Ammonium, then after that is ammonia. So how do you get ammonia gas? You start with ammonium salts and you heat it up with a base like sodium hydroxide. Okay? So this one is often forgotten, so please make sure you pay some attention to it. So at this juncture, all right, if you have the notes, I would like you to turn to this page and make a star there so that you don't forget to study that reaction as well. So this is the fourth reaction that you learn in this chapter. And actually, this is the last reaction already. Okay. So once you are done with your notes, can you give me a thumbs up so that I know that I can continue from here? Okay, I sincerely hope you brought this set of notes home to study. This is acids and bases. If you didn't bring this set of notes home to study, please bring it home on Monday. All right, so my test is on Tuesday. Okay, the next one is easy. pH and indicators. So many words, but in reality, what you need to know is this. Okay, why am I using highlighter? This one. Do we know that universal indicator has different colors depending on its pH, right? So if it's acidic, the color is red, orange, or yellow. But like I said, most acids in the lab will be red. So like HCl, red. Nitric acid, red. Okay? Similarly, alkaline, there's blue and purple, but most alkalis in the lab, like sodium hydroxide, purple. Okay? Can? Finally, what's green then? Green is neutral. So neutral, what's neutral? Most commonly we use pure water as an example. So pure water is neutral, okay? Can? Now, so universal indicator does give you the approximate pH of the solution. That means roughly this pH 2, roughly I can say there's pH 4 based on the color, all right? If you really want an accurate measurement, then you need to use a pH meter. A pH meter is basically a digital sensor, right? That allows you to sense and measure the pH. It's a bit like thermometer is used to measure temperature. Okay, pH meter is basically a digital pH sensor. That's it. All right. So must study the color, okay? Next, soil. So that day I talked so much, about soil. Now, soil is important for growing plants, but plants like all living things, have their own range of pH that they can survive in, right? Just like you, your blood must be a certain pH. If not, you also won't survive. Your organs won't function. So similarly, plants are the same. Plants grow in soil. The soil must be of the correct pH. Now, very often, soil tends to be acidic. But plants don't grow well in acidic soil. As you can see in this diagram, if I zoom in a little bit, then I read for you, okay? You look at it, actually most plants don't like too acidic soil. Too acidic cannot grow. Anything below 4.5 cannot grow already. The plant will die. If the plant dies, the farmer got no money, okay? Now, so basically, you need to ensure that the soil is of the correct pH. So what happens if the soil is too acidic? Let's say if the soil is pH 4, plants don't grow. How can you increase the pH? To increase the pH means make it less acidic. You want to neutralize the excess acid in the soil. Too much acid already. You want to neutralize it. How? We will add calcium hydroxide. Calcium hydroxide is used to neutralize the acids in the soil. Okay? Now, calcium hydroxide is able to do that because it's a base. A base can react with acids to neutralize the acid. This reaction is called neutralization. Okay? Now, you must be wondering why calcium hydroxide, why so special? Why don't you use sodium hydroxide, right? But sodium hydroxide is firstly too alkaline. What that means is that instead of neutralizing and making it neutral, you will go straight all the way to the alkaline range of the soil. Too alkaline, the plants won't grow either. So sodium hydroxide cannot, too alkaline. The next reason is that sodium ions, too much sodium ions in the soil is toxic for the plant. All right, calcium is less toxic. to the plant. All right, that's the reason. Now next, something more advanced. Now this calcium hydroxide that we add, we usually don't add it as a solution. We add it as a solid. You must be wondering why. Why would you spread a solid onto soil? Why don't you just pour the solution in? Surely pouring the solution is easy because the solution will just go into the soil and that's it, right? It will work faster. But that's the problem. If you use solution, then you just pour it into the soil, right? When the rain comes, it will just wash all your calcium hydroxide away, right? Because if it's a solution, the rain comes, it will just wash away, what? Make sense? And that's why when you grow plants, usually the fertilizer, the calcium hydroxide, we add solid. So that when the rain comes, it slowly dissolves and it slowly neutralizes the acids in the soil. You want it to work slowly so that it can last longer, so that you don't have to keep on adding calcium hydroxide every day. It's so troublesome, right? So typically for fertilizers as well as calcium hydroxide, we will add it as a solid. Okay? So calcium hydroxide is used to neutralize acids in soil. Done. Next. And the last one, which is the most confusing sometimes, is the 4 types of oxides. Here we are talking about type or the nature of the oxide. This is the very last page of the acids and bases notes, but it's also often overlooked. So make sure you study this one. It's actually very easy. Now, oxides are basically compounds with oxygen. Oxides can either be basic, acidic, amphoteric, or neutral. Why? Because the oxides may dissolve in water to form alkalis or acids. All right, the oxides can either be basic or acidic or amphoteric or neutral. They display different properties. So how do we know which type is which? Look at the name. The name says a lot. Actually, the name tells you the answer already. Metal. If it's metal oxide, basic. So like sodium oxide, basic. Calcium oxide, basic. Because sodium and calcium are metals. Okay. However, there are 3 exceptions you need to be very familiar with. Zinc, aluminium, lead. These are metals, but they don't form basic oxides. They form amphoteric oxides. Now, amphoteric means it is both properties of acids and bases. It can react with both acids and bases. That's why you see it reacts with both acids and base. Okay? So you must learn these 3 specific examples: zinc, aluminium, lead. But other than that, all other metals, so long as it's a metal, other metals will be basic. So iron oxide, basic. Copper oxide, basic. Silver oxide, basic. Okay? Can? Now we move on to the non-metals. The non-metals form acidic oxides. So it's the opposite. Okay? They form acidic oxides. How do you remember this? Now, if you think about your soft drinks, carbonated drinks contain carbon dioxide dissolved in the drink. The reason why carbonated drinks taste sour is because the carbon dioxide dissolved in the drink forms an acid. That's why we say carbon dioxide is acidic oxide. Okay, carbon is a non-metal, so acidic. Okay, besides carbon, what other non-metals are there? Sulfur, nitrogen. These are also non-metals. So sulfur dioxide, acidic. Nitrogen dioxide, also acidic. Okay? So finally, the last one is neutral. Now, neutral, you just have to learn the common examples. The most common example, of course, is water. Water is neutral, right? Besides that, carbon monoxide, also neutral. Okay? Now, when trying to learn this, I would advise you to learn the basic and acidic first. Learn these 2 bigger categories first. You must know that metal oxides are basic, non-metal oxides are acidic. Learn these 2 first. After you learn these 2, then you go and add on, learn amphoteric, you learn neutral. Because these are more of the exceptions that you need to learn. So the ideal state is by Tuesday, you should know all 4. Okay? It's 5:11. I've kept to my time. So I took 30 minutes to go through acids and bases. Now, this set of notes really is just 6 pages, I think. Or 7, maybe. Okay, but anyway, it's very few pages lah, huh? You should study everything. This contains all you need to know for O levels, not just N levels, okay? At O level, you will not be retaught this topic because you have learned everything you need in this topic for the O levels already. At the Sec 5 year, you're just going to learn new things, new topics, but you will come back to this. You will need this, all right? Now, at this juncture, do we have any questions about acids and bases? You can type. Okay, if you have questions about other topics, please also feel free to ask now. So the other topics meaning mole, meaning metals. You can type if you're shy to ask. Okay. Okay, as you think of the questions, let me tell you what you need to study, okay? Now, the first thing you need to study is, of course, this, the acids and bases summary notes. The second thing that we need to study is, of course, mole. Okay, so this is where your notes comes in handy, right? So what do you learn in mole? Actually, you only learn two things, you know. Mole only got two things, huh? So if you go through your notes, right, wow, you learn something called relative atomic mass. You learn that the relative atomic mass can be obtained from the periodic table, right? So when you go to the periodic table, you will always see two numbers associated with each element. So for example, in this case, manganese. Manganese got two numbers, 25 and 55. Which one is the relative atomic mass? The mass is always the larger of the two numbers, 55 in this case. So make sure you get the correct number. Don't sub the wrong number into your calculation. So once you know it's the bigger number, you also need to know how to calculate things MR. What's the meaning of MR? MR means the mass of the whole molecule, the whole compound. So very often we will set questions like worked example 2, where we give you zinc nitrate. This is an example where there are brackets. When there are brackets, you've got to be very, very, very careful because you need to remember that when there's brackets, you need to multiply the number outside into the brackets. So what do I mean? So like in this case, there's one zinc because zinc is not in the bracket. But what's in the bracket is N. How many N do you have? It's not 1, it's 2. Because it's 2 times 1. Finally, how many oxygen do you have? It's not 3. It must be 3 times 2. So you must count properly and ensure that when you calculate your MR, you add them up properly. So this is 1 zinc, 2 nitrogen, 6 oxygen. You have to add up. Okay? That's why you see 65 plus 2 times 14 plus 6 times 16. Okay? Now, calculating MR is not difficult. Definitely will be tested. The only difficulty is two things. One, please know that when you go periodic table, you must take the bigger number. Okay? 2, when it's bracket, make sure you careful, make sure you add up properly. Okay? So this one definitely coming out. Okay, so be careful. Next. Now, what's the use of MR? The use of MR is so that you can find mole. Now, what is mole? Mole tells you how much of a substance you have in chemistry. All right? The moles will tell you how much of a substance you have. So you need to know the formula triangle for converting between mass and mole. This one is an important triangle. Mass is measured in grams. You can measure mass using electronic balance in the lab. So for example, I can measure like 10 grams of copper, right? So how many mole is 10 grams? You need to use this formula triangle. So how do you use the triangle? Let's say you want to find mole. You want to find mole, you cover N, because N is number of moles. You cover N, you have mass over MR. So you take the mass, divide by the MR. Okay, so we have done a number of questions like this. Okay, we have done a number of questions in the notes. Make sure you go through. Now, as mentioned, we won't test something that's crazily difficult. You just need to get used to all this. Okay, now a lot of these practice questions you should have finished it yourself so that at least we have enough practice. Okay, so I went around in class to mark. So make sure you go through this. Now, for N level, mole is a very easy chapter. There are only two things: calculate MR. Then after that, find number of moles. That's it. So you just need to know MR. You just need to know that formula triangle, the MNMR. Okay? Sure coming out. This triangle, sure coming out. It's not even a secret, okay? It's not a hint. So to use this triangle, you must first know how to calculate MR. MR of substances with brackets in the formula also. So like zinc nitrate just now, that kind of example, okay? Can? So any questions about mole? It's just two sums only, two kinds of problems only. You know? Okay, the next one is the biggest one. Now, you have to study until page 13 of the metals notes. Okay, it sounds like a lot, but actually it's not. All right, it's just 3 parts, but you need to devote time to it. The first part is on physical properties of metals. If you have your metals notes now, you want to take it out now. Okay, let me just give you 1 minute to take the metals notes out so that you know which pages, and I orientate you to what you need to study again. Okay, so if you have your metals notes out, can you give me a thumbs up so that I know that you have the notes with you in front of you? Okay, thank you, Madhu. Okay, the rest of you, do you have your metals notes? Okay, so 13 pages to study. 13 pages includes the cover page there, so actually only 12 pages to study, right? Okay, so I'm just going to go through quickly. So part 1 is on properties of metals. Okay, so there are some general properties such as all metals are good conductors of electricity and heat. All metals will conduct electricity. There's no exception. So long as it's a metal, it will conduct electricity. Okay. Next, however, most metals have high densities. They sink in water. They have high melting and boiling points, but there are exceptions to this. So for example, the group 1 metals, lithium, sodium, potassium. Sodium and potassium are from group 1. They have low densities and low melting points. Okay, so it's not true that all metals have high density, high melting point. There are some exceptions, okay? And finally, if you realize pure metals are quite soft and quite weak, all right? And the reason is shown there. It's about the size of the atoms. You need to be familiar with alloys. Now, because metals are quite weak on its own, you usually mix it with other elements to form alloys. Okay, so why are alloys stronger and harder? Okay, so this is an important diagram to recognize. Actually, at N level, if you flip your TYS, rarely do we make you write the explanation, no. Most of the time, right, it's just, can you recognize from the diagram that this is called an alloy? Okay, so in an alloy, alloys are mixtures of different elements, a metal and other elements. So because it's a mixture, the atoms will be of different sizes. And because they have different sizes, some big, some small, it will disrupt the regular layered arrangement of atoms. And so when a force is applied, it's difficult for the layers of metal atoms to slide over one another easily. So if the layers cannot slide when you push it, then it's not so easy to bend it. It's not so easy to break it. All right, so alloys are stronger and harder than the pure metal. Okay, and that's it. That's it for part 1. Then you go to part 2, which we spent an amount of time to revise this, right? Remember, we did this in class. Okay, we wrote out the reactivity series of metals because we know that the chemical reactivity is not the same. Some are very reactive, like potassium. Potassium is right on top of the reactivity series, so it's very reactive. On the other hand, gold is at the bottom of the series, so it's unreactive. So you need to know the reactivity series by heart. You need to know which metals will react with water, which metals react with steam, which metals will react with acid. All right. So I've already color-coded for you. For water, cold water, only the first four most reactive, potassium, sodium, calcium, magnesium, will react with cold water. So if the question writes, the metal reacts slowly with cold water, the metal is still reactive, okay? Only the most reactive can react with cold water, can. Okay, so next we have steam, and then you have acid. So you have to learn these reactions well, okay? Mr. So cannot memorize for you. You have to memorize yourself. So spend some time, do this summary yourself. How do you do this summary yourself? Take out a piece of paper, use your iPad, okay? Just go to the next 3 pages and write things out lah, right? You have written all these things out once before in the notes. It should be doable for you to write it again on paper. You can refer to the notes while writing it out. That will help you. All right. Okay, the next one, we have displacement reactions. So importantly, you must know displacement is where you have the kicking out. So that day I used the example, right? So for example, I and Silash are a couple. Then Astrin comes in. Astrin is better, therefore Astrin kicks Silash out. Yeah. So that's the idea. The idea is a more reactive metal can displace a less reactive metal from its compound. Okay. So if magnesium can displace copper, that means magnesium is more reactive than copper. Okay. Now, part 2 is the heaviest. So up to page 10 should be the hardest. Then you have page 11, 12, 13, I think. Sorry. Yeah, correct. Correct. 11, 12, 13. Page 11 is on extraction of metals. So metals they are quite reactive. Okay, most of the metals are reactive. Reactive enough to react with oxygen to form oxides. And that's why these oxides, to get the metal back, you need different methods. How? The method you choose depends on the reactivity of the metal. So there are basically 3 categories. The first category is the most reactive. The most reactive metals on top, above carbon, you have to use electrolysis to extract them. Electrolysis means you pass electricity through it. Using the electrical energy, you break down the compound. So for example, sodium chloride, you pass electricity through it. You break it down into sodium metal and chlorine gas. That's how you get sodium metal. Take sodium chloride, pass electricity through it. Now, this is an expensive process because remember, sodium chloride will only conduct electricity when it's molten. So you need to melt the sodium chloride first. So this requires a lot of heating, a lot of electricity as well. That's why sodium is an expensive metal. It's very difficult to extract. Now, for those below carbon, you just need to use carbon. Carbon alone will be able to reduce the oxide. What that means is that it can actually get the metal back, extract the metal from the oxide. Okay. Finally, gold. Gold is very unreactive, so gold exists on its own. Gold doesn't even form the oxide. But the most important perhaps is this. This one got so many things to copy, means obviously there are a lot of details that you need to know. So firstly, you need to know how to extract iron. Iron is extracted from hematite. The rock is called hematite. Contains iron 3 oxide. Okay, you need to know the reactions but you can see Mr. So has kindly put stars for you there on reaction 3, because reaction 3 is probably difficult to write the equation for. So reaction 3 for the extraction of iron is something that you should try to memorize. Okay, now what else should you memorize? You should also memorize what you add into the blast furnace, right? HCl, hematite, coke, limestone. You need to know the function. The function of limestone is to remove impurities. Okay? Maybe for you, learning the diagram is easier. All right.